Hello student, I am Bishwajit Bhattacharjee, Physics faculty of AEP team. Today we will discuss first chapter of class 11, that is units and measurements. It is very important chapter for your board exam as well as NEET JEE exam, because in case of NEET exam there will be near about 3 questions come from this chapter. So that is very important chapter for weightage, that is units and measurement. We discuss about 2 subtopic today, that is fundamental and derived quantity, and another one dimensional analysis. First thing, we know that there is a lots of quantities, you already study lots of quantity like length, mass, time, like velocity, displacement, acceleration, force, momentum, density, current, potential difference, resistance, like lots of quantities already you know that. And there is a 2 different types of quantities. One is fundamental and another one is derived. Okay, one is fundamental, another one is derived. Which are fundamental quantities? The quantities which are independent in any other quantities, like say length. Length is the unit of length is meter, and that is independent of any other quantities, right? So that is a fundamental quantity. Like mass, unit is kg, which is independent of any other units, right? That is also a fundamental quantity. Time, unit is second. Temperature, unit is Kelvin or degree Celsius, degree Fahrenheit, you know that. That is independent of any other quantities. Current, electric current, that is ampere. Okay, ampere. Amount of substance, that is mole, basically mole. That is also independent of any other quantity. And luminous intensity, that is candela. Basically it is not in our syllabus, candela. So these 7 quantities are basically fundamental quantities. The quantities, basic fundamental quantities that doesn't depend on any other quantities is called fundamental quantity, and these 7 are the basic or fundamental quantity. And which are derived quantity? Like derived quantities are those which are obtained by combining fundamental quantities using mathematical relation. Okay, that means say speed. What is the unit of speed? Speed, you know that distance by time, and the unit of distance is meter and time is second. That means unit is meter per second. That means this meter is the unit of length and this second is the unit of time. That is combining of these 2, you get the unit of speed, right? So these are the derived quantity, because this is depend on 2 or more fundamental quantities or derived quantities. Okay, like force, you know that mass into acceleration, and the unit is mass is kg and acceleration is meter per second square. That means the unit of force depend on kg, that is unit of mass, meter, that is the unit of length, and second, that is the unit of time. So this is a derived quantity. Okay, next one is area. Area is the length into breadth. Unit is meter square, and this is combination of 2 length unit, right? Meter into meter. So this is also a derived quantity. Density is the mass by volume. Okay, mass by volume. So unit is kg per meter cube. kg per meter cube. This is also a derived quantity. So these are the derived quantity which are depend on the one or two or more fundamental quantities or derived quantities. These are the derived quantity, okay? And each quantities we use some use some symbol. This is known as dimension, okay? Dimension of a derived unit are the powers to which fundamental units of mass, length and time etc. must be raised to represent that unit. If you represent a unit or quantity, you have to use some fundamental or some derived quantities, then these are the called dimensions, okay? Dimensions, like say this is three fundamental quantities, length, mass and time. Basically we can use this only three quantities, and length has symbolically represent as L, mass represented by capital M and time represented by capital T. So dimensions are L, M and T, okay? We use some derived quantities, dimension of derived quantities, like dimension of derived quantity. Like say first area. What is the dimension? This is basically length into breadth, you know, length into breadth, and the dimension of length is L and dimension breadth is also L. So the dimension of this area is L square. Like volume. Volume, you know that length into breadth into height both are dimensionally L, so the dimension is L cube, okay? And the dimension always written in between a third bracket, okay? Third bracket. Say density. Density, you know that mass by volume. Mass by volume, that is mass is capital M and volume is L cube, that is ml to the power minus 3, okay? Like say velocity or speed, that is displacement by time, you know that displacement by time, and the displacement, dimension of displacement is L, time is t, so Lt to the power minus 1. Acceleration. Acceleration basically change in velocity by time, right? Change in velocity by time. Change in velocity by time. Change in velocity is meter per second and by time is second, that is meter per second square, so Lt to the power minus 2. Acceleration. Force is equals to mass into acceleration, so m L t to the power minus 2, right? Say work done. Work done is the force into displacement, so m L t to the power minus 2, that is force into displacement L, that is ml square t to the power minus 2, okay? Work done. Say power is work done by time, so m L square t to the power minus 3 power. Energy is same as work done, okay? Because the unit is same, the unit of work done is joule also, unit of energy is joule, so the work done and energy has same dimension, okay? Power. Pressure is force by area. Force is m L T to the power minus 2 divided by L square. So it will be m L to the power minus 1 T to the power minus 2, that is pressure. Okay, say momentum. Momentum is mass into velocity. Mass into velocity, that means m L T to the power minus 1, that is momentum. Okay, these are the common dimension of common for derived quantity. Okay, you have to memorize all the dimensions in this quantities. Okay, next, why dimensional analysis is very, very important. Okay, first thing, if you say you know a relation, but you don't know the unit of a unknown quantity. Okay, but you know the relation of this quantity, you can find unit or dimension of this quantity by the dimensional analysis. Like if you know the gravitational force, the first thing, use of dimensional analysis. First thing, you can find the unit or dimension of an unknown quantity. To find unit of unknown quantity, right? Number two, you can establish a relation between some fundamental or derived quantity. Okay, you can establish some relation to derive relations between two or more quantities. Okay, two or more quantities, you can find the relation. Number three, say you know that the unit of force in CGS system is dyne and in SI system is Newton, and you also know that the relation between Newton and dyne. But in case you have an unknown quantity and you know the units of the quantities in a CGS system and SI system, what is the relation between the two different units? You can find from the dimension analysis. Okay, so you can convert unit from a system to another system, right? From a system to another system. Okay, and number four, you also can establish a relation. Say you know a relation, but is it wrong or is it right? You can find dimensional analysis. Okay, so basically these three are very important. Okay, and number four is analyze the relation is true or false, or false. Okay, these are the uses of dimensional analysis. Okay, these are the uses of dimensional analysis. First thing, we can find dimension or unit of unknown quantity. We can establish a relation between the quantities, and also we can convert unit from a system to another system, and analyze a relation is true or false. Okay, first thing, to find the unit of unknown quantity, say gravitational force. Gravitational force between two masses, you know that the relation is F equals to G m1 m2 by r square, where m1 and m2 are the two masses. M1 and m2 are the two masses, and their separation is r. Then what is the unit of this quantity? That is capital G, which is known as gravitational constant. Okay, so you have to you already know the units of m1, m2, r and f, but you don't know the unit of G. Then we can find from the dimensional analysis what is the unit of G. Okay, say here G equals to, we can write F r square divided by m1 into m2, right? Then what is the dimension of F? That is m L t to the power minus 2, and distance is L, so L square divided by m into m, that is m square. So the dimension will be m to the power minus 1 L cube t to the power minus 2, sorry, t to the power minus 2. Then what is the unit of gravitational constant? The unit of gravitational constant is, meter cube per kg second square, right? Meter cube, that is L cube. L cube is meter cube per kg second square. That is the unit of capital G, right? Unit of capital G. Say another one example, viscous force. Viscous force. Viscous force in a liquid basically depend on, viscous force is equals to, formula is eta AV by R. This symbol is eta, which is called coefficient of viscosity. This is called coefficient of viscosity, and it is unknown for you, right? You don't know the coefficient of viscosity. And what is the unit of coefficient of viscosity? But you can find the unit of coefficient of viscosity from the dimensional analysis. How? That is, A is area, V is velocity, R is distance, and F is force. Okay? A is the area, V is the velocity, R is the distance, and F is the force. Then eta equals to, obviously eta equals to F into R divided by A into V. F dimension is m L t to the power minus 2, L is R is L, and area is L square, and velocity is L t to the power minus 1, you know that. So here m is m, and there is L square, and denominator is L cube, so L to the power minus 1 and T to the power minus 1. So the unit of eta is kg per meter per second. That is the unit of coefficient of viscosity, kg per meter second. Okay, kg per meter second, that is the unit of coefficient of viscosity. Okay, the unit of unknown quantities. Next use, that is, we can find also we give some example, like say in a equation, say a relation is given, that is F equals to P into T plus Q. Here F is force, T is time. You have to find the dimension of P and Q. First, you give an answer, like if I ask that the summation of, what is the value of summation of 10 kg and 20 meter? You know that it is not possible, because 10 kg and 20 meter summation is not possible because the unit is different. You can summation 10 kg plus 20 kg, that is 30 kg, but you can't addition in two different quantities, like so. Here is plus, so if this total term and this total term have same dimension, because if you add these two terms, you obviously there is the same unit of PT and Q, right? 10 kg plus 20 kg, and the result is 30 kg. 30 kg means this is force, right? So these three have same units or dimensions. If we addition, or in case of addition and in case of subtraction, obviously the each term will have same dimension or unit, otherwise you can't. So we can write the dimensionally F and PT are same, so P will be F by T. F is force, the dimension is mLT to the power minus 2, and T is time, so T, so the dimension of P will be mLT to the power minus 3, right? mLT to the power minus 3. And also here PT and Q have same dimension, so, and also the F is same dimension, so we can write the dimension of Q is the dimension of F, so the dimension of Q will be mLT to the power minus 2. Okay, this is the dimension of P and this is the dimension of Q. Is it clear? Next, you do the numericals. Say V equals to P square into T minus, say, root Q. Then what is the dimension of P and Q if V is represented as velocity? V equals to velocity and T is the time. Okay, V is the velocity and T is the time. Then what is the dimension of P and Q? Then you can write P square T and V has same dimension, So we can write P square T is equals to V. So P will be V by T. So V is LT to the power minus 1 and T is T. So LT to the power minus 2. That means root L T to the power minus 2. That means it will be L to the power half and T to the power minus 1. The dimension of P will be L to the power half, T to the power minus 1. And what is the dimension of Q? Obviously, dimensionally, you know that root Q is equals to V. That means Q equals to V square. So, the dimension will be L T to the power minus 1 whole square, that is L square T to the power minus 2. That is the dimension of Q, right? So if you know the relation between some quantities, then you can find all the dimensions of the unknown quantities, right? Next, say a relation that is basically a van der Waal equation, that is P plus A by V square whole into V minus B is equal to constant. This is called van der Waal equation, and here P is the pressure, P is pressure and V is volume. You know the dimension of pressure and volume. You have to find the dimension of A and B, and also you have to find the dimension of constant, say this is K. You have to find the dimension of K also. Then how can do this sum? We can write that here P plus A by V square, that means dimensionally P and A by V square is same, right? So dimensionally you can write P equals to A by V square. That means dimension of A is equals to P into V square, and you know the pressure, dimension of pressure, that is M L to the power minus 1 T to the power minus 2, and V is L cube whole square. So the dimension of A will be M L to the power 5 T to the power minus 2. That is the dimension of A, right? And there is V minus B, V minus B. So here sign is minus, that means the dimension of B and dimension of B is same. So the dimension of B will be the same as dimension of V, that means L cube, right? Dimension of B is L cube and dimension of A is M L to the power 5 T to the power minus 2. Then what is the dimension of K? That is constant. You know that these total value represent pressure. Basically, this total value represent pressure, that means unit is Pascal, and this total value represent volume, that is meter cube, right? Then K will be basically dimensionally P into V. We can write P into V, pressure into volume, that is M L T to the power minus 1 T to the power minus 2 whole into L cube. So M L square T to the power minus 2, that is the unit of K, and you know that this unit is basically the unit of work done or energy, right? Say that means K basically represent work done or energy. Okay. Next, a relation V equals to P into T minus Q plus S by R into T. See, this is a relation Q plus S. Here V is velocity, T is time, S is displacement, you have to find the dimension of P, Q and R. You have to find the dimension of P, Q and R. Here you know that the dimension of PT, dimension of this total term and dimension of velocity are same, right? So you can write P into T is equals to V. That means P equals to V by T. V is the velocity, so it is Lt to the power minus 1 by T. That means the dimension of P is Lt to the power minus 2. Okay, Lt to the power minus 2. Next, here Q plus S, the summation between Q and S. So dimensionally Q and S are same. So the dimension of Q will be the same as the dimension of S. That means this is L, right? The dimension of Q will be L, and dimension of total, that is Q plus S, that is L, divided by R into T is same as Lt to the power minus 1, right? Lt to the power minus 1. This is basically T means this will be capital T, right? So R will be Lt to the power minus 1 by Lt to the power minus 1, that is 1, right? 1 means dimensionless, that is m to the power 0, L to the power 0, T to the power 0. The dimension of R is m to the power 0, L to the power 0, T to the power 0, that is dimension of R. Okay, say next one. Say there is a equation, say V equals to Pt into sine of Q into S plus R. Here V is velocity, T is time, and S is displacement. Okay, then you have to find the dimension of P, Q and R, right? You have to find the dimension of P, Q and R. Here this part is represented by an angle, right? Because sine of this, that means sine of we can write sine of 60 degree, sine of 30 degree. That means these are the this total term basically represent a angle. So that is dimensionless. You know that angle is dimensionless. So Q into S plus R both are dimensionless. So we can write Q into S is the dimensionless. Dimensionless means 1. That is dimension of Q is 1 by S. So the dimension of Q will be L to the power minus 1. And what is the dimension of R? Obviously that is dimensionless. So dimension of R is m0, L to the power 0, T to the power 0. That is dimensionless. Okay. And this total term is also dimensionless. That is a pure number. Say sine 60. That means you know that root 3 by 2, sine 30 half. So that is pure, that is obviously a pure number. So dimensionally V is equals to dimensionally P into T, right? We can write this. So P will be V by t. V by t means L t to the power minus 1 by t. That means L t to the power minus 2. The dimension of P is L t to the power minus 2. This is the process to find the dimension of unknown quantity. Next class, we discuss about the to find a relation between some quantities. Okay, this is for this class. In next class we discuss part 2. Okay, thank you.